Okay, so today's date is 3/12.
Wait, where are we? We can't see it.
3/12/18, and we are talking about exponential functions, okay? So as we talk about exponential functions, I always like to tell a little story, okay, about growth, exponential growth. So here's my little story. You guys watching? So let's say, and if you already know this, or you've already heard this lesson, just bear with me. So let's say you go home and you tell mom and dad, hey, for the month of March, and if you know this, just watch. Day 1, I will do everything. I'll wash the dishes. I will vacuum. I will clean. I'll do everything you want. And all you got to do is pay me 1 penny. No, wait. Then on the second day, I want you to double my wages. And I'll do everything. I will do everything. And you can pay me 2 pennies, right? And on the third day, I will do everything. I will wash the dishes. I will scrub the floors. I'll do everything. And you can double my wages. And I'll work for 4 pennies, okay? Now, here's the guess. There's 31 days in March. Okay, I want you to just think. On the 31st day, how much money do you think mom and dad are going to have to pay you?
31 cents.
I'm gonna guess
Okay, I heard 31 cents.
$40.
40 bucks. Anybody else?
I don't, it was huge, I don't remember that. Wait, can I do it? I get it.
We're going to do it real quick. Anybody guess? Okay, I've heard 40 bucks, right? What if I told you it was about, well, let's check it out. Let's see what it might be. So if it's 0.01,
Can't see it.
if it's 0.01 and we double the wages, right? And we do that for 31 days, right? Are you ready? Are you ready? Before you say, no way, Mr. Davies, you are crazy. I am not going to ask my parents to do it. That is $21 million they will have to pay you. They will have to pay you on the 31st day. Now, that doesn't count the $10 million that they had to pay the day before. And that does not include the $5 million they got to pay the day before that. So if you were to add up all the money that they're going to pay you, it's just about you are set for life. Now, you think that 1 penny, I could do this. I could do this. If somebody was really going to pay me and double my wages every day, and I knew I was going to have $21 million on the 31st day, oh my goodness, I would take that bet. And I'd work my fanny off knowing full well that eventually I'm going to hire somebody to do the work for me, right? Isn't that sweet, right? So I'm going to get to about day 15, and I'm going to pay somebody to do the job for me, and I'm going to take the money, right? So that is a great example of Annika Talents here, but not Annika. So this is a great example of exponential growth, right? Now let's go back to this. So you ready, girls? So let's do this. All right, anything to the 0 power. Anything to the 0 power is always 1, right? So if we plug in, and we're going to go, 2 to the 0 power is 1. 2 to the 1 power is 2. 2 to the 3 power is 2 to the 2 power is 2 times 2, which is 4. 1, 2, 3, 4. 2 to the 3rd power, guys, 2 to the 3rd power, 2 to the 3rd power is 2 times 2 times 2, which is 8, which is up here. Do you see how it curves up? It has this shape. Now, 2 to the negative 1 power, well, let's check that on my calculator. What is 2 to the negative 1 power? It is 1/2, but I'll prove it to you. 2 to the negative 1 power is 0.5. 2 to the negative 2 power, 2 to the negative 2 power is the same thing as 1 over 2 squared, which is 1/4. 2 to the negative 3 power is 1 over 2 cubed, which is 1/8. It will never touch. You're totally right, DeAndre. So this shape graph is the same shape you had when you did the Skittles, right? It's exponential growth, isn't it? Okay. Now, DeAndre's right. It has a horizontal asymptote right here. and my horizontal asymptote is at y equals 0. That's the line y equals 0. And DeAndre's right, it will never touch. If you go half of a half of a half of a half of a half, you get smaller and smaller and smaller, but you'll never get to 0, right? Okay, the domain of this, it's forever wide, is all real numbers. All real numbers. The range never touches. DeAndre's right. So the range is from 0, not at 0, but above 0. So it's going to be y is greater than 0. And it is growth. All right, now we did example 2 in the warm-up, so let's do example 2 again. Right? So if we took anything to the 0 power is 1 times 48 is 48. 1 half to the 1 is 1 half times 48 is 24. So 1, we're going to go to 24, approximately 24. 1 half to the 2 power is 1/4 times 48 puts you at 12. So what we're doing is we're going half, and then half of that is 6, half of that is 3, half of that is 1.5. And again, we're going to have a horizontal asymptote at y equals 0. There's my horizontal asymptote at y equals 0. If I were to graph the line in, it looks something like this. And this is exponential decay. All right, pretty simple so far, right?
Yeah.
Okay, let's turn the page.
We directed them.
Oh, thank you. Domain, all real numbers, right? And the range is y is greater than 0. Again, never touches 0. Never touches 0 and goes up from there, okay? Ready to turn the page?
Davies, when organic matter is too old to use carbon-14, what do they use? I know they use something else.
I don't know.
Yeah.
We'll find out. Stubbs or Mass,
I
you'll
have it in
know.
my head that it's uranium, but I don't think it's not uranium if it's organic matter. So.
It might be.
No.
Okay.
Uranium.
Let's do example 3, okay? You guys ready? Shh. So first of all, write this equation down, okay? We're going to write f of t equals a1 plus or minus r to the t. Write that equation down. I'm going to highlight it. F of t. So it's f of t because it's a function over time. It's a function over time. A is my girls. Morelia, stop talking. It's gonna drive me crazy. I'm trying to teach.
I'm listening.
Thank you.
I had to like talk. Other people are talking to you.
You are amazing that you can listen and talk at the same time. Me too, huh? Okay.
I'm multitask.
Thank you. Let me teach. So, A is the beginning amount. 1 is your, you know why we need the 1 there. The 1 gets us our original amount. Plus or minus. If it's growth, it's plus. And if it's decay, it's minus. To the t power, which is time, okay? Now, so let's write an equation. So Tony purchased a guitar for $12,000 in 2010. Experts estimate the guitar will increase in value by 14%. So an equation I'm going to start with is f of t equals. Now the beginning amount was 12,000 times, and it is growth, 1 plus, in this case, 0.14, because that's my rate, to the t power. Okay, there's my equation. And I can use this equation to solve this problem for any particular time, okay? So graph this function. Well, one of the things I know is it's going to have to start at 12,000. So I'll put a dot right there at 12,000. Now, I'm going to use my calculator to help me get values for 5 years, 10 years, and 15. So if I do that, I'm going to use my calculator. First I'll put 5 in there, and I'll go 12,000, and I'll go 1 plus 0.14 to the 5th power, okay? So about $23,000 for 5 years. So I know this is just going to be 23,000. It's about there. If I need 10, I'll use my calculator. And I'll go, all right, I can use my calculator to get that. I can go 12,000. 1 plus 0.14 to the 10th power, and I get an answer of about 44,500. So I'll go to about 44,500 is up there. And for 15, I might be off my chart, but I'll just try it anyway. 12,000 times A1 plus 0.14 to the 15th power. It's about 85,000, which is probably off my paper. So it should look something like that. Now, I got 15 to be at 85,000. Yeah. Okay. Now, what will be the value in 2020? So let's see. If 2010 is our first year, then 2022 has got to be the 12th year. Does that make sense? So I'm going to let t equal 12. And so I'll do this one down here. We'll go, all right, f of 12, because the function after 12 years is equal to my 12,000 times 1 plus 0.14 to the 12th power, okay? And I'm just going to let my calculator get my answer for me. Okay, if I can get that so you can see it clear. So we're going to go, let's see if I can slide it, they can see it, there we go. We'll go 12,000 times 1 plus 0.14 to the 12th power, and I get an answer of about 57,000. Must have a pretty valuable guitar, huh? $57,814.85. Maybe it was a Jimi Hendrix guitar, I don't know. Right? Now, when will the guitar be worth 60,000? There's two ways to do this. One is to guess and check. That's a pain. The other way is just to graph it. Let's graph it. So one of the things I want to do is, if I do a graph, I'm going to use some common sense in my graph, okay? I'm going to graph this. So before I do anything, I'm going to look at my window. Girls, let's please, if you're going to drive me crazy today, it's going to be talk while I'm trying to teach. So please, just wait until I'm done teaching, and then you can talk as much as you want. Okay, so, I'm going to graph this. So I think 0 to 15 gets me to, 15 got me to 85. So 0 to 15, right? Y scale, I can go 0 to, I know I've got to get to 60,000, right? So I may as well make this, well, let's make it 70,000. Okay, so my scales are set up in my calculator to hopefully find the answer to 60,000. All right, now I'm going to put the equation in my calculator. I'm going to go 12,000 parentheses 1 plus 0.14 to the power of x, because it does x, not t. Okay. Now when I graph this, I'll see my exponential graph. It's got the right window for me, right? And there it is. And that looks like the graph we're looking at. So if I want 60,000, I'm going to use my trace button, okay? So use my trace button, and I'm going to try and find out when the y value is 60,000. So I keep going, 60,000, 60,000. So pretty close to right about there, about 12.3 years. So about 12.3 years is what I get. Okay, so I get t equals about 12.3 years. Okay. Now, what we want to find eventually this week is how to do this problem without having to use the graph. And there is a way called logarithms, which is what we're going to learn. Logarithms are actually pretty easy. It's a really handy way for us to solve for the exponent, okay? That's where we're headed. Let's look at example 4, okay? So in example 4, where it's going to depreciate. So we're going to use the subtract. So equation, let's go f of t, function over time. We start with $28,000. We're going to go 1 minus. 1 minus because it depreciates. And by 9.5% as a decimal, that's a 0.095, right? As a decimal, 0.095 to the t power, okay? There's my function. Okay, so let's graph the function. So let's plug in 5, 10, and 15. So I'm going to use my calculator to plug that in. I do know it starts at 28,000, so I can put a dot right there. Year 0, 28,000, okay? Now, I'm going to evaluate 5, 10, and 15. I'm going to put in my calculator, so I'm going to go ahead and go, all right, see if you guys can see this. So I'll go my 28,000. 1 minus 0.095 to the 5th power. And I got 17,000. So for 5 years, I'll go to 17,000. About there maybe. Estimate. Okay. So now I'll do the same thing, but I'll do it for 10. I'll go 28,000 times 1 minus 0.095 to the 10th power. I get about 10,300. So I'll estimate 10,000. And for the 15th year, again, I'll use my calculator. Okay. We're going to go 28,000. 1 minus 0.095 to the 15th power. You got to. I can't teach while you guys are gabbing. About 6,000, right? About there. Okay, so if I sketch it in, it's going to look something like this. Okay? Okay. Now, what will be the value of the truck when it's 5 years old? Well, I think we already did that one, but we'll do it again, okay? For 5 years, let T equal 5, right? And I'll go 28,000. 1 minus 0.095 to the 5th power, right? For 5 years. And I'll use my calculator to get that answer. So I've already done it once, but I'll do it again. 28,000 times parentheses 1 subtract 0.095 to the 5th power, and I get about $16,998.12. So it's about $16,998.12. Okay. How many years will it take to be worth 5,000? Well, it's going to be a ways, right? So again, the only way we can do it is to graph it and find out the 5,000. Okay, so how do you graph it? When I do this, the first thing I do is I set up my window. Okay, I want to set up my window so it matches this window. Does that make sense? So if I go to my window, 0 to 15, I might go further than 15. I might go 0 to 20. Minimum 0, the maximum is only 30,000. I could probably go to 30,000 here. Okay, so I make my window fit my graph, right? Make my window fit my graph, the graph that's in front of me here. Y equals, let's put in my equation, 28,000, parentheses, 1 minus 0.095 to the power of x, right? And let's graph it and see what we get. Okay, it looks just like what I have on my paper, right? And now what I'm looking for is I'm going to trace it to 5,000. Trace. So I'm waiting for the y value to be 5,000. Okay, it's getting there. I'm at 78, 7,000. I'm at 6,000, 5,000. Probably right about there, about 17.2 years. Now again, I'm going to teach you an easier way to do this week. But for 5,000, I've got t equals about 17.2 years. Okay, and again, this is what we want to learn this week. Okay, so if we can do page 493.